How does structural analysis predict building behavior? Imagine standing in front of a towering skyscraper or a sprawling bridge, marveling at its strength and stability. Have you ever wondered how engineers ensure these structures will stand firm under various conditions? The secret lies in a process called structural analysis, a vital tool that helps predict how buildings will respond to forces and loads they encounter during their lifespan. Structural analysis begins with creating a detailed model of the structure, incorporating all its components such as beams, columns, walls, and foundations. Engineers assign specific properties to each element, including material strength, stiffness, and dimensions. This model serves as a virtual replica, allowing engineers to simulate real-world scenarios without physical testing. One of the key aspects of structural analysis involves calculating how forces distribute throughout the structure. When a building experiences loads, such as the weight of the building itself, furniture, occupants, or environmental forces like wind and snow, these forces generate internal stresses. The analysis determines how these stresses are transferred through the structure's elements. For example, in a high-rise building, the weight of the floors creates compressive forces on the columns, while lateral forces from wind create bending moments and shear stresses. Engineers use mathematical equations based on principles of physics and mechanics of materials to evaluate these forces. Techniques such as finite element analysis divide complex structures into smaller, manageable parts called elements. Each element's response to forces is calculated, and the results are combined to understand the overall behavior of the entire structure. This process helps identify areas where stresses may be too high or where deformation could occur. Structural analysis also considers safety margins by applying load factors, ensuring the structure can withstand unexpected forces or material weaknesses. It predicts how the structure will deform under load, whether it will bend, twist, or experience other movements. This information guides engineers in selecting appropriate materials, designing reinforcement, and determining the optimal placement of structural elements. In essence, structural analysis acts as a predictive blueprint, revealing how a building will behave before it is constructed. It ensures safety, durability, and efficiency, enabling engineers to design structures that can withstand the test of time and nature's challenges.